This video is going to walk you through working with the Unreal Engine 4 Shaders and Effects Cookbook, Section 6, Advanced Material Techniques, and working on the brick wall using displacement. So in previous examples, especially earlier on, we worked with our normal map to give our fine surface details that kind of give the illusion of more geometry. The video previous to this one, we created a parallax occlusion mapping, which also still is just visually moving the pixels on the screen to give the um, illusion of like a high poly model. It looks a lot better than the normal map, but ultimately it is still moving the pixels and it's putting the work on the GPU, which may be what you want, but if you have a decent system, you're trying to make a really high-end scene, what you might want to work with instead is using world displacement. World displacement, also in combination with a tessellation on it, will give your model more actual geometry and will displace those vertices on your geometry. So we are getting like an actual physical displacement of verts in here rather than the illusion through moving pixels around instead. So bonus is that, we're having actual geometry being moved. Downside is that it is going to end up being a very high poly scene, possibly with this. So there are some tricks you could do to kind of help with that, especially setting things up so that like the distance away from what has the material like cuts down on things, like setting up LODs type, like a LOD type situation. But this is probably like the more higher end, like if you want like the best, is you'd want to work with world displacement and tessellation. So we're going to start in our scene and we are going to create a new material in here. Let's name this one. I'm going to right click, create material. I'm going to name it M underscore brick wall underscore displacement. And I can't quite see that. There it is, right there. And I'm going to put this on the wall so that we'll be able to see it. So let me kind of move in a little bit closer. And this is going to be a lot less complex than the parallax stuff. So there's not as much to this. So it might ultimately be a little bit easier to set up. So the first thing we want to do in here is we do need to make a quick change to our main node here. So I'm going to scroll all the way down in the details panel until I find tessellation, which is right here. And by default, this D3, D11 tessellation is set to no tessellation. So we are going to actually turn this on to be PN triangles. And we are going to change the max displacement to 100. You could try kind of messing around with some of these settings, like maybe change it to flat tessellation, maybe put on crack-free displacement, and like kind of manipulating these later on. It might be a good thing to kind of play around with, see if you can see any differences. But they do have other changes in here that you could possibly do to that. So once we have that, let's work on actually setting up our world displacement right here. So I'm going to hold T and click for a texture sample and search for T underscore wall. And I'm going to use that wall depth image that we used in the last one. We're going to add a scalar multiplier, a scalar parameter with this so that we can affect the contrast. We're going to call it contrast intensity because this is going to be used to affect the contrast on our image, so that we can change the push and pull of it so that, if you need to tweak it, we can adjust it through that scalar parameter, how strong this effect is. So I'm going to hold down S and click to make a scalar parameter. and call it contrast intensity. And let's just set it to 1. You can always come back and mess with this later to see what it does. And we're going to feed this into a cheap contrast. So let's find cheap contrast. And the texture sample goes into this one, and this intensity goes into that one. All right, so we have the contrast one. We do need to have another scalar parameter for height intensity. Hold on 1 second. So let me make sure I clarify. We're going to do height intensity, which is different than contrast intensity, what we already have set up. This one increases the contrast of that texture so that the distance between the pushed and pulled areas is greater. So like the overall contrast of it between the highs and the lows, where the height intensity will just be like an overall kind of control to that. So I'm going to hold down S and click. Oops, sorry. There we go. And call this one height intensity. And let's just set this to 1. And again, once this stuff is all done, come back in and make changes to these like individually and see what happens. Just so you have an understanding of what they're doing. So let's now feed this into a multiply. So we got that one into there. We'll do a multiply for this one. And the last thing we need to do now is we need to find where that vertex is in space so that we can appropriately displace it. So I'm going to put it up here. The node we're looking for in order to find that vertex's location is a vertex normal WS. So vertex normal world space. So where is that vertice in space? And we are just going to then have another multiply so we know where it is and we know where we need to put it. I'm going to move this down some. And then this is going to get fed right into our world displacement right here. I don't think you can see anything yet on here. Oh, just a little bit. It's kind of hard to see until we get some more stuff going. But we're going to be able to see stuff happening soon up in there. So I'm going to make this a little bit bigger. Okay, so we have our world displacement, but what this is actually going to be doing is moving our vertices on our object. And if I change this to brush wireframe, like we don't really have a lot of vertices yet on here. So one of the ways that we can go ahead and add more vertices to our wall or any model that we use is through a tessellation. You might have used tessellation and not realize that's the term for it in programs like Maya. When you do like that mesh smooth stuff, you're basically tessellating it. There is like an actual tessellation you can do as well, but it's more or less taking the geometry you have and dividing it to get more geometry. Since we do actually need physical, vertices that exist on here to move in and out. If we don't have that that geometry there, it's not going to move. So we can kind of see it sort of starting here. You kind of see it's a little bit wavy, but we don't really have enough geometry on here to do that. So we are going to work with creating a tessellation multiplier, which is this, and we're just going to give it a scalar parameter. So I'm going to hold down S and click, And let's call it, what should we call it? Subdivision amount. And let's feed that into here, so into our tessellation multiplier. So right now it's set to 0, and let me, I'm going to change this over quickly to that brush wireframe. So we don't have any tessellation going on. You see that? It's kind of hard to see with that dome in the background, but you should be able to see, so I'm kind of wiggling it back and forth. A subdivision amount of 0, we just have our basic plane. Watch what happens when we change this now to 5. Like, let's give it a subdivision value of 5. We suddenly have a whole bunch of geometry to work with, so that we should be able to start getting some displacement on there. So let me change it back to lit. You can kind of start to see it working probably a little bit better. But, you know, keep in mind, the more you tessellate, the more polys you're going to have. And if you're working in a not heavy CPU, like you don't have a very good CPU, you're going to run into frame rate issues because of that, because it's going to have to work with all of these polygons now. Sometimes though, polygons in a game, as far as like keeping your frame rate low, might be cheaper than the GPU. Again, depends on your system and what you're working with. So, you know, just be aware of these different types of ways to manipulate the surface and what works, you know, what would ultimately work the best for the situation. So, okay, we got that. And now we just need to set up our, the rest of it. And this is just going to be using the same things that we used for the previous one, the base color, roughness, and AO, and normal. Let me first, before I forget, I'm going to make a texture coordinate node so that we can make things tiled. I just created this by holding down U and clicking. And we are going to tile it, I think it's 7. Yes, if we want to keep up with the book, a U and V of 7. And let's just feed this first into here. Trying to get it close so you'll be able to see it. And then we'll add our 3 maps, texture maps we need up here. So I'm going to click 3 times while holding down T. 1, 2, 3. Let's kind of move these up. Oops. There we go. This one is going to have our T walls. The depth. This one is T walls AORM, and this one is T walls normal. We could feed these all into here too to make sure that these tile correctly. And we could start hooking these up. So this is going to go into base color. And you can really kind of start to see where it's working now. Don't worry, it's going to look a lot better in game. We could even turn it on. Does it work better on the sphere? I don't remember. Let's see. You can see it'll look better on our wall model. Okay. R goes into the ambient occlusion. G goes into our roughness. Last, we need to put our normal map into normal map. And I believe that's it. All right, let's apply and save. And check it out. So now, if we go to the side, we're actually displacing those pixels. Remember I said, oh, in the parallax one, we don't get like this definition here. So we are getting it. It is doing it based off of that map. So, it's not, we do have a little bit of this kind of issue here. Um, that's just based, if we pull out, it's fine. Um, you just wouldn't want to get super crazy close to that. But hey, we were able to tessellate it and displace it. There are lots of fun things you could possibly do with this. So think about, for instance, your living slime that you created. If you really wanted to make it deform itself, like if you had like a slime model, you could make it kind of burble based on doing this kind of stuff instead, and it will actually displace your model. So this one was definitely a lot quicker, but again, this is definitely a much more CPU intensive one versus the other one that pushed things to your GPU. So just kind of keep that in mind. But definitely learn how to do this kind of stuff because it will give you a lot more possible interesting materials to work with in Unreal.